In this section, we will look at persisting data with MongoDB. Starting up a MongoDB with Docker Compose and adding the MongoDB dependency to the project. First of all, MongoDB is a NoSQL database. This means that it actually stores JSON or JSON documents in the Mongo database in something called collections. It is very flexible and easy to use since it can contain anything. It is released under the server-side public license SSPL, which is based on the GNU General Public License version 3. This means that we can actually use it. It has a Docker image that we can use out of the box. The software needed to run the MongoDB as a Docker container. We need Docker, of course. Docker is the container engine that we will use in this course. We are using the Docker Community Edition and the latest version. We need Docker Compose. Again, use the latest version. The installation procedure is a bit different on every operating system, but both Docker and Docker Compose is available for macOS, Windows, and Linux, like Ubuntu or Linux Mint, for instance. Docker Compose. We will use a Docker Compose.yml file to start and stop the MongoDB. The file looks a bit like this. First, we have a version of the Docker Compose content. Then we are mentioning some services, and here we have a MyMongo, and there we have an image, and we are using Mongo and the latest Docker image. We are exposing the port 27017, and that is because then we can connect to it from our application. We need to add the dependency to the build.gradle file, and the current version is 3.12.3, and this is so we can access the MongoDB database. Setting up a Mongo client. We need to configure a Mongo client and register a Podio codec registry to convert the objects to JSON documents and the other way around. The code looks a little bit like this, but do not worry, we need to set this up once and then it runs. If we have a Mongo database distributed on another server, then we need to set the connection string on the Mongo client settings builder. Right now we are just using localhost, so that means we do not need to provide a connection string because localhost and port 27017 is the local port and host. Now let us write some code. I have prepared this project right here. The first thing we should look at is the Docker Compose YML file. This is what will actually give us a local Mongo database that we can use for development. Here we can see we have the version, we have the services part, and we have the name. We can type whatever name we want to type right here. Then we have an image. Right now we're using Mongo and then the latest version. We need to expose port 27017, or else we cannot reach it from our application. So let us start this Docker container. It is quite easy. We navigate to the script folder. I've already done this in this terminal right here. And then we write Docker Compose and up. If we want to run it as a daemon, then we also add -d for daemon. This means that if I'm breaking this console right now, then if I press Ctrl-C, then everything stops. But if I run it as a daemon, then it will run in the background. It is up and running now without any problems. So let us try to use it. First of all, let us look at the dependencies that we have added. I have my MongoDB driver right here, 3.12.3, and then I've chosen to use Jackson in this example right here. Or else everything is actually just like we're used to. In our application.kt file, right here, we can see that I have set up a Mongo data handler. This is my own class, so I could have named it anything. Some people also like to name it service instead, like Mongo data service. Doesn't matter. It could also be spaceship data handler, since this data handler right here handles the spaceship. That means that it persists them in a Mongo database, and it can also extract them from the Mongo database collections again. But nevertheless, I have declared a Mongo data handler right here, and I'm using that in the endpoint, all ships right here. And here I'm responding with whatever result I'm getting from the all spaceships function. So let us try to go and see how that class looks like. Here we have the Mongo data handler. I have declared a database right here. I have declared spaceship collection right here with the type spaceship. So that means that this collection only contains spaceships. And the reason why we do this is because then we can have a Podio codec registry right here that we set up right here. And that can actually convert the spaceship into Bison. Here we are building the client, the MongoDB client. And if we want to set a new connection string, then we can just say apply connection string like this, and then I can give a string like localhost on my server or whatever. But right now it is okay with the default values because I use localhost and I use port 27017. Here I'm getting the database. I've chosen to name this dev. It could also be development, so it's a bit easier to read like this. Development. And of course we could configure this and place this in a configuration file if we wanted to do that instead. But right now we are focusing on getting started. So here we have the spaceship collection. I'm getting the collection. And here I need to give a name. This is the name, logical name it will have in the collection name it will have in the Mongo database server. And then furthermore, we need to attach a type. This is the class type, the object type that we want to store inside this collection right here. And that means that then the Podio codec register can then convert this automatically for us. Then I initialize some spaceships right here. So whenever I start up my application, then I create 4 spaceships like this. And then I can return all my spaceships right here. It's actually a list that we're returning, but we find, and of course it is a list of spaceships, list spaceship. And we can use now the spaceship collection, and then we call find on the Mongo database. And since we have no criteria on the find, that means that then we will get all the spaceships that are located inside that collection. Then I'm going through each of them and just printing them out. This is just for debug reasons I'm doing this. I'll delete this code, of course, whenever I feel confident that everything works as it should. And then I return Mongo result. This is an iterator, so we need to call to list on the iterator. Let us try to run the application and see if it works. Now the application is started. Let us just wait a little bit because we can actually see that we get a lot of output regarding the connection to the Mongo database, like this. Right now we can see that we're checking status of the Mongo database and that everything looks fine and all that. So we get some more output. It can be turned off with the log level. Right now this is log level debug. And here we have the classes that are outputting it. That is the MongoDB driver. Let us start up a browser. First of all, yes, hello world, that works. So far so good. Let us write all ships, like this. And now I get all my ships. The ID is converted because this is an object ID. This is Bison ID that we get from Mongo, from MongoDB. Then we have the name. This is our own values. And then we have fuel. And again, we have name and fuel, test 2, test 4. So that's fine. It actually works. We are up and running. Yeah, we are connected to the Mongo database. The last thing that I can show you is the spaceship class that we have right here. It's defined as an object ID. We have a name right here. We have a fuel right here. And when we create a data class like this, we also need to create an empty constructor. And that is because else the Podio converter cannot convert it into types or into the Bison. So we need an empty constructor like this, a secondary constructor that then calls a primary constructor like that. The primary constructor is the one that we see up here in our data class. So that's actually it.